Hey guys, what's going on? We are going to learn about variables in Golang. So let's dive straight in. What are variables? For those new to programming, variables are just how we store data, and we can kind of describe the data as we want and do what we want with such variables. So let's dive in. For those obviously who've seen some variables in other languages, but there's different types of variables. So let's dive in. So we talked about strings and ints previously. So strings and numbers. Just a string is this type of data, and an int is just like a number. Okay, so previously in those two types should be fairly self-explanatory. This would be an example of a Boolean. We have false or true. Excuse me, it's lowercase in Golang. Okay, so we have meaning it has a true or false value, the floating point, the float type. So we have float 32 and 64, I believe, and float 16. And this would be if we want to define a variable with decimals, right? Okay, so let's keep moving. Okay, so are used for numbers that are not integers, that they have digits on the right of the decimal points, such as 3.14159. The float 32 uses 32 bits of precision, while the float 64 uses 64 bits to be able to more precisely store more digits on memory. Don't worry too much about the intricacies of the other types for now. We will cover some of them in more detail as the course progresses, but the main key ones we need is integer, float, boolean, strings. Those are like we're gonna run into them. Okay, so declaring a variable. Variables are declared using the var keyword. For example, to declare a variable called number, the type is int. We can write it like this. So if you're familiar with, let's say JavaScript, we'd say my var equals this, right? This would be my variable, right? This is a var, right? If we're familiar with Python, we would just go ahead and say my var equals this, and we say this is a Python variable, right? And then if we want Golang, there's actually two ways to do it. So we could say var, we could say my var, and then you have to declare the type. So string, say this is a Go var. But there's also one way that I imagine we're probably going to learn here on this journey, which is we can actually assume the type by doing my var, and then we do a colon equals, say this is also a Golang variable. Boom. So this into an assignment operator, it shows that, or it actually assumes the string variable. So that's the same way to do it in 3 different languages. Let's keep moving. So here's a variable, and it's a float 64 declared with the 3.14159. Okay, so the assignment here, initialize variables from print statement, or from the print statement. So we need all of these to int, float 64, boolean, string, with their 0 values respectively. So I don't think we need to assign them to anything. We could just say, I'll say var sending limit, and we'll say int for this one. I think we could do int 64, I believe. Let me copy this down, and we'll say var cost per SMS. Maybe we'll do a float. So I'm sure it would be a decimal value. We'll say float 64, and has permission. You already know that's going to be a Boolean. So it's bool, and then username, say var equals string. Okay, let's give that a run. Let's see what it does. See if that passes our code. We'll see. So we didn't declare anything. We just made the variables. Wonderful. So I don't think we needed to be specific on that, but it worked. Okay, so short variable declaration. Inside a function like the function, boom, we have the short assignment statement that could be used in place of the var declaration. That's what I was talking about just in that previous lesson. So this assumes the type, this semicolon equals, assumes the type. So let's just skip forward. We don't need to read much more about it, but you understand that it assumes the type. So again, if we have some variable, if we declare it as a string, this is a string. The same exact way to do that, just with that new type, is just with that. This is a string. And if we hovered over it in VS Code or some IDE, NeoVim or something like that, it would potentially, I actually don't know if NeoVim has help windows, but it would show string. It would let us know that that's assumed to be a string. Okay, so let's go to the assignment. Many of our users send birthday messages using the Textio API. Finish the main function so that it says, happy birthday, you are now 21 years old. Okay, so we're going to steal that string. I see. So we have message start. So basically we need to break that into 3 pieces. So we have message start, age. Interesting. We may need to convert that into a thing, which let's see, you are now, say boom, you are now, put it in a string as well, and we'll say years old. Okay, let's run it and let's see. This section needs a space. Happy birthday, you are now 21 years old. Wonderful. Okay, moving forward, type inference. To declare a variable without specifying an explicit type. So that wasn't the last lesson. What was the thought? I thought the last lesson was this, right? The type inference, right? Okay, so just re-instantiating that thought, we can infer the type, and you can see it already does it. Oh, there's a complex 128. Had no idea what that was. Okay, but so here's all the types for these things. So this is already going to declare an integer. If we have a test, right? And this is a string again, this will already declare it's a string. So it does do type inference, which is awesome. You might be saying, well, why do we want to do types? And you might want to define the type first for the data that you're using, depending on your API, depending on all that stuff. So you might run with both syntaxes. You may find it useful to do this just for speed, but if you do know your types, you probably want to define the type a little bit more explicitly. Or if like you have contracts and you want to match types, all that fun stuff. So, okay, so assignment. Our current price to send a text message is 2 cents. However, it's likely that the future price will be a fraction of a penny. So we would use a float 64 for this, okay, to store the value. Interesting. So edit the pennies per text declaration so that it's inferred by the compiler to be a float 64. So we could just say 0.02. Let's submit, and it'll make it a float 64. Wonderful. And this is how we can declare some of that stuff, is the FMT package. There's a format package. There's a print statement. There's another thing. I think we could do value as well. It would say pennies. There's a few of these. So let's run that. And it should say the value. Let's remove. Let's see value. Maybe T. Let's see. How do they do it? Maybe it's a little bit different in their code editor. Boom. There we go. Okay. So we could get some values, some types. There's a few others. I think B is one of them. Let's see, for binaries. Okay, so there's a lot of things you could do with this formatting package. This is kind of like their console log for those familiar with JavaScript. This is their console log, and then or their print if you're familiar with Python. Okay, let's keep moving. So sorry guys, I got to keep an eye on the time. So same line declarations. You can declare multiple variables on the same line. So we have mileage, company, boom. You can see it shows the mileage and the company. It's like a destructure type thing. Okay, so the above is the same as this. That's kind of cool. All right, so assignment. At the top of the main function, declare float by average open rate. Okay, and we'll say display message, and we'll make it all the same. So the first one is going to be a float, it looks like, and the second one is going to be a string. So I forgot an I here. Let's submit and move forward. We are cruising right along. That's pretty cool. That is pretty cool. 23% open rate's pretty good, by the way. So type sizes, ints, uints, floats, and complex numbers all have type sizes. The size 8, 16, 32, 64, 128 represents how many bits in memory will be used to store the variable. The default int and unsigned integer types refer to the respective 32 or 64 bit sizes depending on the environment for the user. The standard sizes that should be used unless the developer has a specific need are int, uint, float 64, and complex 128. Some types can be converted like this, okay? Casting a float into an integer this way truncates the float point portion. So it's going to take off all those decimals. It'll just, boom, take the 88. Assignment. Our Textio customers want to, side note, I wonder if it does a math ceiling or a math.floor. So if it's like 88.7, would it round it up to 89 for us, or would it just truncate it and say it's still 88? We'll find out. But okay, so our Textio customers want us to know how long they've had accounts with us. Follow the instructions in the comment provided. You will create a new variable called account age integer, which will be a truncated integer of the account age. Okay, so I imagine we could just take we'll build the account age integer, and then we'll wrap this in account age. I think we could do account 64, and let's try. So it does a math.floor. It looks like it literally just, or it doesn't do either. It just literally deletes the decimal. It doesn't take that into consideration. Cool. All right, moving forward. When should you not elect to use the default type? When performance and memory are the primary concern. We'll just shoot from the hip. First one, let's go. What does the type or what does the size of a type indicate? Bits. And we're moving forward, guys. Oh, boom. That was, oh, okay. We have a little bit more. I thought that was the end. It's like, wow, we cruised through that. It was too much fun. Too much fun. Okay, so constants are declared with the const keyword. They can't use the boom short declaration syntax. So we still have const, but I think it's a little bit different. I still redefine stuff in JavaScript all the time, or in TypeScript even all the time with const. You can like reassign it, or you could do more things with it, right? Plus some data, or even if it's like some operator with like, or some object with data, right? You can even just take like the var, right? The var and put more things in it, right? Like there's a lot of ways to mutate data that I'm traditionally useful with TypeScript that I don't know are going to work with Golang, which I'm super curious about. Super curious, because I think that's why it makes it so quick, is because it's much more statically enforced than Python, or than Python, that's true, but also TypeScript, because those are dynamic programming languages. Okay, so constants are declared with the const keyword. They can't be used with the short declaration syntax. Constants can be character, string, boolean, all our types. They cannot be more complex types, like slices, maps, structs, which are types we'll explain later. As the name implies, the value of a constant can't be changed after it's been declared. It's constant. Use two separate constants. Something weird is happening in this code. What should be happening is that we create two separate constants like premium plan name and basic plan name, okay? Right now it looks like we're trying to overwrite premium plan name, which is not going to work. So complete the code and remove the bug. I think we just need to make that a const, and we are off to the races. Perfect. Okay, so computed constant. Constants must be known at compile time. They are usually declared with a static value. So compile time happens before runtime. Like the code gets compiled down to bytecode, and then it gets ran on the server. So the reason why Golang is so powerful, as I think I referenced in the previous part, which is it's static. It's like all the compile time errors are handled, or all the runtime errors are handled before compilation. So when you deliver it to the server could just shred through the statically typed code a little bit quicker and with less memory. So, okay, so however, constants can't be computed as long as the computation can happen at compile time. For example, this is valid. Boom, first name, Lane Wagner, boom, full name. Okay, so that said, you cannot declare a constant that can only be computed at runtime like you can in JavaScript. This breaks. So the current time now can only be known when the program is running. So that's kind of what I was talking about, is how you can kind of manipulate the data on that variable a lot easier. My programming brain was built around JavaScript, so I'm going to have to kind of unpack a few bits probably in understandings of software and try to take a different approach with Golang. So I'm super excited. Okay, so keeping track of time in a message sending application is critical. Imagine getting an appointment reminder an hour after your doctor's visit. Wouldn't be a good reminder. So complete the code using a computed constant to print the number of seconds in an hour. Okay, so seconds in an hour I think is just 60 times 60, right? Is that all we needed to do? I felt it didn't really teach us compile errors. But okay, so formatting strings in Golang. Go follows the printf tradition from the C language. In my opinion, strings formatting interpolation in Go is less elegant than Python's F strings, unfortunately. Format printf prints formatted strings to a standard out, and we have the sprintf, which returns the formatted string. Okay, so I think one is printing, one's returning, I suppose, which I think is just slightly different. Okay, so default representation, the %v variant allows Go syntax to be represented in a value. So similar to Python's F strings or JavaScript's backticks, that's how we declare stuff in a message. So if we want to specify something in print, you could use the following formatting verbs. Sprintf, this is where the string is going to go. So this is kind of the S variable or the value. We store it there, and then we could punch it in wherever we need it. Okay, so let's see, integer. That's how to do an integer. So they have to be a little bit more specific, I suppose, or Golang is a little bit more specific, which I'm going to have to be very particular with, right? Because I'm very much just blasting through code. So I'm super curious how Golang is going to go. Pun intended. Okay, so create a new variable called MSG on line 9. Okay, so we'll say MSG. It's a string that contains the following. Boom. Let's copy it, and here we go. So percent new line. And I think what we could do is replace, let's see, replace the norm. So we want to do format print F. Let's see. And we're going to pop something in both sides. I imagine maybe the message or something. Replace name with the name variable. Okay. So we'll say name goes here. Let's see how this is going to work. So we're going to pop this right here, and we'll say, what would it be? %V right here for a string, or %S, I think, for strings. Boom. Yep. String right there. Okay. Replace open rate variable with, now how do we do this with multiple? Do we need to declare more of them? I see we do. Okay. So this is going to be the first bit of data. We'll say message. I wonder if you can re-manipulate the data, this, multiple times. I imagine you can. So we'll do this. How would this work though? Okay, so %, we'll say open rate, rounded to the nearest tenths. So we'll just go ahead and put 10.5 and open rate. I don't know if this will work though, because we have a string thing here now. A new line. Okay, so %D, let's see. Yeah, I don't know if we can reassign this multiple times. All right, cool. We'll pop it. Look at the solution. Oh, you actually can. So %S, %1F, and new line. Okay, good to know. And it was %1F here, boom, and backspace new line. Let's try that. Mismatch one variable, but printf returns 2. Maybe we need to do sprint f. Boom. Let's see. Close. Your output is only a few characters off. What did we miss? New line, new line, new line. All right, we're going to take a little peek. See? So high %S. Oh, there we go. Simple mistake. Simple mistake. Boom. Moving forward. Okay, so conditionals. If statements in code do not use parentheses around the condition, boom, like this. Else if statements are supported, you might expect very similar to kind of C syntax or JavaScript syntax. Fix the bug on line 12. The if statement should print message sent if messages length are less than or equal to max messages. Cool. Alrighty, we're moving on. Why would you use the initial section of an if statement to keep the code to confuse other programmers? Nope. Wait, so how does this look? Oh, I see. So you got if initial statement. Interesting. So an if conditional can have an initial statement. The variables created in this initial statement are only defined within the scope of the if body. Why would I use this? This is just some tactic sugar that Go offers to shorten up the code in some cases. So in some cases, so we have if length less than 1. So we define the variable first and then the statement. Super interesting. Okay. So to speed up the code, we want to keep it concise and the scope limited. That sounds appropriate. We're into the challenges, folks. We got 2 challenges. Let's try to cruise through them because I got to pop off before 10. So format practice. Textio has asked you to log in individual users and their recent messages. Assignment, create a user log, variable or on line 15, and it should contain all of these things. That's a few things. So we're going to say user log just right away. Just want to get that down, right? We'll say fmt sprint f, and we'll pop that all in there just to immediately have it, right? So we know exactly what we need to get for. So where f name, l name, age, message rate, is subscribed, and message are all corresponding to the variables of. Okay, so let's start plugging them in. So f name, we'll say %s right there. Last name, ooh. You know what we could do is actually just say full name, right? We'll say f name plus last name. That needs to be proper casing. So casing is a little bit different, but we'll go ahead and just pop that in for last name and full name with a space. Wonderful. Age we'll pop in here. I think it's %d if I'm not mistaken, right? For integers, %d, and the rate is going to be one of these floats. So we'll say %.f or 1f. There it is. Is subscribed is going to be a Boolean. How do we do Booleans? T. Okay, so %t and pop that Boolean here and subscribed. Let's see. I wonder if we could just pop it in. Similar thing, just message right here and another %s. All right, let's see. Money. Money, folks, money. On to the next challenge. Okay, so this is an optional challenge. You could skip to the next chapter if you would like. Let's peek around. We're here now, right? Might go poorly, but let's find out. So calculate balance. We need to be able to calculate the cost of an entire batches of messages at once. Using the given variables, write conditional statements to calculate and update the variables. First, set the final cost, the bulk message cost, right there, okay? If the user's premium, the discount should be applied. Okay, so I think what we can do is say, if user premium, how do we do? The discount should be applied. Final cost and the discount rate. So final cost equals, we'll say this times discount rate. It'll be bulk message cost, I imagine, times discount rate. Oh, a discount rate of 0.20. So do we reassign it here? Is this doable in Golang? Will I get errors? No. Insufficient funds? Oh, looks like tests. Wonderful. Okay. The reason why I was testing that was just to see if we'd get some red line errors real quick, to see if the compiler would let us know. Okay, so next, a discount. Okay, let me reread this. So first, set the final cost to the bulk message cost. If the user is premium, then the discount rate should be applied to the final cost. A discount rate of 0.20 means the discounted price per message would be 80% from the original price. So, I don't think we need to do that. I think it's already declared here. So the discount, I see. So we need discount rate 1 minus the discount rate. So we're 100%, or so it's out of 100%. So it'd be bulk message cost times 90%. Okay, so next, if the user has enough money in their account balance, process the payment deducting the final cost from the account balance. So if premium user equals final cost, let's see. Then basically we want if account balance is greater than final cost. Forgot that syntax here. Print, let's see, so we'll say FMT, print line, else. Oh, okay, so we need to do one last thing. So if account balance is greater than final cost, we need to deduct the payment. So account balance equals account balance minus final cost. Okay, let's run it. Let's see. No, we are insufficient. Message not declared. All right, I'm going to drop it in ChatGPT real quick, see what we're missing. Little Golang never killed nobody. I thought that would be just about it though, right? So it looks like you're trying to implement a scenario where a user could take a bulk purchase of messages. However, there are a few issues with the code. The code final discount rate, final cost while using the book creates a new variable. Instead, you should assign it. Okay, so we should just assign it to this. And likewise here, it says you could actually just do the shorthand. Oh, okay, let's try that. And then it says insufficient funds message. Oh, my bad. I was thinking too programmatically here. Boom, here we go. Okay, wonderful, wonderful. We've done it. We've gone. Wonderful, guys. That's fun learning a little syntactic sugar, and Golang is obviously a very, very, very powerful language. You can see why. Hi, Coop. Did we get a little cameo? A little Coop cameo? Come on, show the people. Come on, buddy, show the people. Let me wrap it up here. Guys, but thank you so much for learning some Golang. I do got to pop off because I do have a meeting at 10. So, he got me down. But thank you so much for watching. I hope you learned something about variables in Golang. I sure did. And next, we're going to tackle some functions. I will see you soon. Cheers.